Now that we've done a lot with matrix transformations, let's look at some specific properties that we can have for these transformations. The first I want to look at is surjective, or onto. Let's suppose I have some transformation T going from Rn to Rm. There are a few different ways to define this. The first is going to be every vector in Rm is the image of at least one vector in Rn. If you pick any vector in your codomain, you should be able to find something that maps to it. In other words, the range in the codomain should be the same. Since we know that linear transformations and matrix transformations are the same, we can talk about this in terms of matrices. If our transformation is surjective, then there should always be a solution. In other words, when we row reduce, we should not have a row of zeros. If we have a row of zeros, then we would be not surjective, and if we don't, it would guarantee that we are surjective. The other property that we have is injective, or one-to-one. And once again, let's consider our transformation going from Rn to Rm. This says that every vector in Rm is the image of at most one vector in Rn. So it could be the image of one vector or zero vectors. So it doesn't guarantee that our solution always exists, but if they exist, then the solution should be unique. In other words, no free variables. If we're row reducing our matrix, we should not have any free variables. If there are no free variables, then you're injective. If there are, you are not. Let's look at some examples of these two. Here is a matrix already in row echelon form. We can see there's no row of zeros, which means it is surjective. In addition, there's no free variables. We have pivots in all of our columns. So therefore, this would also be injective. So this one would be both. If I look at this particular matrix, we can definitely see a row of zeros, which tells us it is not surjective. And then if I look where my pivots are, I have one in the first column and the second column, but not the third column, which indicates a free variable. So this one would be not injective. So our first one was both, and our second one was neither. If we look at this matrix here, we can see that there's no row of zeros, which tells me that it is surjective. And if I look at my pivots, I have one in the first column and the second column, but not the third column, which means I do have free variables. In other words, it's not injective. So this one is surjective, but not injective. Finally, this matrix right here, we do have a row of zeros, so not surjective, since we can't guarantee a solution always exists. If I look at my pivots, I have one in the first column and one in the second column, which means I don't have any free variables. So this one would be injective. So my first one was only surjective, my second one was only injective. And I was only able to look at these very nicely because my matrices were in row echelon form. If they're not, we may have to row reduce them before we can actually determine if things are surjective or not.